In this video, we are going to continue evaluating trig functions within the coordinate plane. So let's take a look at now the actual signs, positive versus negative of the trig functions in the different quadrants. So remember, we talked about reference angles. So reference angles are you're gonna have, like, if this were your angle, then So if this were your angle, then your reference triangle is going to be drawn here, and this is where you're going to get all of the trig functions. You're going to evaluate all the trig functions from this. Or if your angle had a terminal side in the second quadrant, then your reference triangle would look like this, drawn to the x-axis, and from those side lengths, you're going to get all of your trig functions from. Or if it was in the third quadrant, okay, then your triangle again is going to be drawn up to the x-axis, and those side lengths are going to help you determine all of the trig functions. So when we're thinking about this, you want to be thinking about how the functions are for sine. So sine is going to be y over r. Okay, so let's take a look at when the sign is going to be positive or negative. So if you remember the r value, this is always positive. Okay, so always positive. So this means that the sine function itself is going to be positive or negative depending on the y coordinate. Okay, so depending on the y coordinate. And the y coordinate, remember, is the height here. So if the y coordinate is positive, the sine is positive. Okay, and similarly cosecant as well, because cosecant is going to be r over y, r always being positive again. Okay, so when the y value is positive, sine is positive. When the y value is negative, sine is negative. Okay, and we know just from our understanding of ordered pairs that in the first quadrant, the x coordinate is positive, the y coordinate is positive. Okay, in the second quadrant, the x is negative, the y is positive. Third, x is negative, y is negative. And fourth, x is positive, y is negative. Okay, so this means, so if we want to know when is the sine function positive, okay, so sine is positive in the first, positive in the second. Okay, because it has a positive y value. So I'm actually going to write it like this because this is how you're going to see it. Okay, so sine is greater than 0 here in the first and the second. In this one, okay, let me just highlight this y coordinate here so that you can look at it. In this one, the y coordinate is negative in the third quadrant. So in the third quadrant, the sine is negative or less than 0. Okay, and I should probably have a theta in each of these. And in the fourth quadrant, okay, the y coordinate is negative, so the sine is also going to be negative. Okay, then when we do cosine, so remember cosine is the x coordinate over the r coordinate, so secant is going to be the r over the x. Remember, again, the r value is always positive. Okay, so the cosine is going to gravitate towards the x coordinate. So if the x coordinate is positive, the sine is going to be positive, and the secant. If the x is negative, the cosine and the secant are going to be negative. Okay, so again, in this first quadrant, we've got the x value is positive and the y value is positive. Okay, of all the ordered pairs in the first quadrant. Second quadrant, x's are negative, y's are positive. Third, x's are negative, y's are negative. Fourth, x is positive, y is negative. So for the cosine is going to be positive in the first, so greater than 0, negative in the second, less than 0, negative in the third, and positive in the fourth. Then tangent. Tangent is the x coordinate, or sorry, tangent is the y over the r, or opposite, which is always your height, and adjacent, which is always your horizontal. So tangent is y over x, so cotangent is x over y. So now the x and the y coordinate, okay, if they are both positive, tangent is positive. If they are both negative, tangent is negative. Okay, or sorry, tangent is positive. If they're both negative, then tangent is positive. If they are different, then tangent is negative. Okay, so if you take a negative divided by a negative, you get a positive. If you take a positive divided by a positive, you get a positive. If you have one of each, then you get a negative. Okay, so again, first quadrant, both are positive. Second quadrant, x negative, y positive. Third quadrant, x and y are negative. Fourth quadrant, x is positive, y is negative. So if they are the same, okay, if they're both positive or both negative, tangent is positive. Okay, so tangent is positive in the first, tangent is positive in the third. Okay, if they have one of each, okay, then tangent is negative, because a positive divided by a negative is negative. So tangent is less than 0 in the second and the fourth. Then we have quadrantal angles. Okay, and quadrantal angles means that their terminal side is a multiple of 90 or pi over 2. They end on the axis. Okay, so when you have an angle that ends on the axis, remember if it's here, okay, up like this, that means that the x coordinate is 0 and you have a y coordinate. Okay, here you would have a negative x coordinate and a 0 y coordinate. Here, you would be 0 for the x, negative y, and here you would be at positive x and 0 for the y. So when you're doing this, okay, so if you're trying to evaluate, say, tangent of 90, okay, so tangent is always y over x. Okay, so you'll take the y coordinate divided by the x coordinate. So y divided by 0. So this is going to be undefined because you can't divide by 0. Or if you were doing the cosine function, okay, cosine of 90. Cosine is x over r. Okay, your r is always 1. Okay, we look at these as 0, 1. We're going to get into this when we get to the unit circle. But we just look at these as the easiest one possible. So we would say that this is 0, 1, this is negative 1, 0, 0, negative 1, 1, 0. So then your cosine at 90 is going to be equal to your x coordinate, 0, and your r is always 1. Okay, so cosine is just going to be 0. Or sine of 90, you'd be looking at your y over your r. Okay, the y coordinate is 1, the r is always 1. So then the sine is going to be 1. So then you can also take a look at when they go through an ordered pair. So if an angle is in standard position and its terminal side passes through the point negative 7, 9, so if I change this angle here to go through this point, negative 7, 9. Determine the 6 trig functions from it. Okay, so now this one I'm going to draw the reference triangle. Okay, so I'm going to draw the triangle down to the positive x-axis, or down to the x-axis. Okay, so here's the reference triangle. Now I don't know this angle. They didn't give me the angle. I mean, I could use inverse trig to find it, but I'm not going to. But they have this coordinate here, okay? So this value right here is negative 7. This one is 9. So then I can find this third missing side by doing the Pythagorean theorem. So 81 is 9 squared. Negative 7 squared is positive 49. Add those together. So 81 plus 49, and you get 130. So then this one is square root 130 for that side. So then you'd be able, now you have them all filled in, okay, and here's your theta. So now you're just going to do all of these 6 trig functions from this filled in triangle. So sine is going to be opposite 9 over hypotenuse 1 square root 130, and you could rationalize that. So then this is going to be square root 130 over 9. Cosine would be adjacent, negative 7 over hypotenuse square root 130. So then secant is going to be the flip of that. Tangent is going to be opposite, which is 9, over adjacent, which is negative 7. So cotangent is going to be the flip of that. So they give you an ordered pair. You can draw a triangle with those as your x and your y coordinates, or your legs of that triangle. Solve for the missing side and then fill them all in. So which quadrant does theta lie in if the following statements are true? So now they're going to tell you something about the positive, negative nature of the signs, of the functions. So remember, tangent is y over x. So this is saying tangent is greater than 0. That happens when either y and x are both positive or they're both negative. Okay, so tangent is greater than 0 in the first and the third. So I'm going to cross these out because tangent is negative in the second and it's negative in the fourth. Okay, so we're down to quadrant 1 and quadrant 3. So then we also have to decide, when is sine less than 0? Remember, sine is the y coordinate over the r. So sine is less than 0 when the y coordinate is negative. Okay, well, the y coordinate is positive in the first, so that doesn't work. Okay, so third quadrant is when sine is less than 0 and tangent is greater than 0. So this was quadrant 3 for this one. Okay, how about when sine is greater than 0? So again, sine is y over r, so this is when the y is positive. So sine is positive when y is positive, and that's in the first and second. So sine is negative here and negative here, so that wouldn't work. And then cosine is less than 0. Cosine is x over r. Okay, so when cosine is negative, when the x is negative. Okay, x is positive in the first, so that wouldn't work. X is negative in the second, so cosine is negative in the second. So cosine of theta is less than 0 here, and sine of theta is greater than 0 here. Sine goes with the y, cosine goes with the x. So this is quadrant 2.